So now let us look at this subtopic, magnetization of magnetic material. So what do you understand by this topic? Basically is the process of making a magnet from a magnetic material. So if you have a magnetic material, you can make it into a magnet by conducting a number of processes. So these processes are referred to as magnetization of magnetic material. So we have 4 methods of magnetizing magnetic material. So 1, we have the induction method. 2, we have stroking. 3, we have hammering. And 4, we have electrical method. So these 3 are the common methods of magnetizing a magnetic material. So let us discuss them all one by one. So first of all, we will start with the induction method. So what is induction method? What do you understand by induction method? So let us say, for example, you have a magnet. This is your magnet here, and then this part is the south pole, and this part is the north pole. So, and then let's say you have pins. You bring a pin and then stick it at this part here. So what will happen is that this pin will become magnetized. So what do you think will be the polarity of this pin if we put it like this? So the polarity of this pin will be, because this is the north pole, then this part will be the south pole, and then this part will be the north pole. So if you add another pin down here like this, then this pin, the downer pin, this part will be the south pole and this part will be the north pole. So through this process we have been able to magnetize these pins. So this method is known as the induction method. So to prove the polarity of this magnet, you can do this. And then let us say, for example, this is the north pole and this is the south pole. So you can draw the pin down here like this. So you'll realize that there will be repulsion between these two pins. Why do you think that is happening? So the reason why there will be repulsion is because, remember, this one is the south pole. So this part here of the pin will be the north pole. This part will be the north pole. And this here down here will be the south pole. This will be the south pole. And remember, we said that like poles repel each other and unlike poles attract each other. And because this is the south and this is the south pole, then the repulsion will occur here between these two pins. What do you think will happen if you bring a magnet, and this part being the south pole and this part being the north pole? What do you think will happen if you bring this magnet towards this part here? Now remember, this is south and this is south and this is south. All these are like poles. So what will happen is that this repulsion will become even more, because unlike poles repel each other and like poles attract each other. So this is the simplest way on how you can prove the polarity of these pins. So in simple terms, you're supposed to say that the end of the pins attracted to the magnet, so this part here, the end of the pins attracted to the magnet, acquires a polarity that is opposite to that pole of the magnet. So this pole is the south pole. So at this part here, where the pin meets the magnet, it acquires an opposite polarity, which is the north, which is opposite to the polarity of the magnet to which it is attached to. And also you can say that the lower end of the pin acquires a polarity similar to the pole used. For example, this is the lower part. The lower part will be now the south pole. So this south pole will acquire the same polarity to which the pole of the magnet was attached to. Even to this example, you can see we have used the north pole. So the lower pin will receive the same polarity as the part to which the pins has been attached to. So this lower part will be also the north pole. So that is a shortcut or a shorter way of knowing the polarities of these pins. So now that is all about induction method. Now let us look at the second method, which is the stroking method. So what is stroking method? Stroking method is whereby you stroke a magnetic material. So let's say, for example, you have a magnet like this. Then let's say this is the north pole, and then this part is the south pole. And then down here you have a pin like this. So this is your needle. You can call it a steel needle. Now during stroking, what you're supposed to do, you're supposed to rub this magnet. So let us say, for example, in this case, we rub this magnet toward this direction, like this. So we are rubbing this magnet along this steel needle. So what do you think will happen? So we always say that the observation made is that the needle aligns itself with the magnetic axis of the earth, whereby one of its end is repelled by the plotting compass. So if you put a plotting compass from one end of this needle, then it will deflect the plotting compass. So the fact that it repels the magnetic compass, basically it says that this needle has actually been magnetized. Now what do you think will be the polarity of this needle? So we have, let's say, call this point A, and let us call it point B. So what do you think will be the polarity of point B? So the polarity of point B will become the south pole. So B becomes the south pole and A becomes the north pole. So we always say that the end of the needle where the magnet finishes stroking, so the end of the needle, this part where the magnet, this magnet here, finishes stroking, it acquires an opposite polarity to that of the stroking end. So if you look at this one is the north pole. So the end of the needle will acquire an opposite polarity to which the stroking magnet has been used. So if this one is the north, then this part will be the south, and that's why we have said that B becomes the south pole of this magnetized material, and this part here, this A part, becomes the north pole. The disadvantage of using this method is that it produces magnets in which one pole is near to the end of the magnetized material than the other. One side, the pole will be nearer to the end than the other. For example, you can say that this part becomes the south pole, but now the north pole will not be to the farthest end. The north pole can be around here. So it produces magnets in which one side of the magnet of the poles is farther to the end than the other. So normally what we can do to counter target that disadvantage is by using the double stroke method. So what is the double stroke method? We can draw a diagram of a double stroke method. So let us say we have like a steel rod. So this is a steel rod. Now remember, we are now using the double stroke method. So in a double stroke method, what we will do is we will use two magnets. So this will be magnet 1, and then this one will be magnet 2. So what we normally do is we stroke. Let us start with this magnet. So this magnet should have opposite polarity. So if you use this one as the south pole, then this one you should use as the north pole. So we should stroke this first magnet in this direction, and this other one we should stroke it in the opposite direction, like that. So remember, we said that the farthest end of the steel rod will always acquire a polarity opposite to the polarity of the magnet, the side of the magnet that has been used. So for example, here we have used the north pole. So at the farthest end where it finishes stroking, it will acquire an opposite polarity. So here will be the south pole, and here we have used the south pole. So the farthest end will require an opposite polarity of the north pole. So here we have been able to counter target the disadvantage of this, whereby we said one of the polarity is farthest to the end than the other. So here all of the polarities will be on the farthest end. So this one will be the north pole, and this one will be the south pole of the magnet, and this method is known as the double stroke method. Now what do you think will happen if you use the same polarities here? Now, let us say, for example, let me clear this. Let's say, for example, what do you think will happen if we change the polarities of this magnet? We use the same polarities, this one becoming the north pole, this one becoming the north pole, this one becoming the south pole, and this one becoming the south pole. So I remember we said that at the end of the bar, or at the end of the stroke, it will acquire a polarity that is opposite to the polarity of the side used in stroking. So if this is the north pole, then definitely this part will be the south pole, and if this is the north pole, then definitely this will be the south pole. Now remember, this part where you start stroking will become the north pole, and this one will become the north pole. So this is the polarity of the magnet if you interchange and use the same polarity of the magnet during stroking. So you will have a magnet that looks like this. So this is a magnet with a consequent poles at the center, whereby this part is the north pole and this part is the south pole. So we have the same polarity at the middle. So the most important thing you need to know is that at the end of stroking, it will acquire a polarity that is opposite to the pole used by the magnet during stroking. So this one is the north pole. So definitely at the end of stroking, this part here will be the south pole. So up to this point, we have looked at induction method. We've also looked at stroking method. Now let us look at hammering method. So how do we magnetize a material in this method? Now let us say, for example, you have a steel bar like this, then you have your hammer here. So this is your hammer. So how can you be able to magnetize this steel bar by hammering method? What you're supposed to do is that you're supposed to align this magnet in the Earth's magnetic field. So we are supposed to align it like this. Let's say this is the Earth's magnetic field. So this being the north pole and this being the south pole. So you're supposed to align it parallel to the Earth's magnetic field, and then one end of the bar magnet should be hammered by this hammer. You hit one end. So when you hit it, this steel bar will get magnetized, and that is the simplest method of magnetizing a magnet using hammering method. You just have to align. Remember, it is very important to align this steel bar with the Earth's magnetic field. So you need to align it. You need to place it in a north-south direction to be parallel with the Earth's magnetic field, and then you're supposed to hammer one side of the steel bar, and then this steel bar will become magnetized. So now let us look at the last part of method of magnetizing magnetic material, which is the electrical method. So how are you supposed to magnetize magnetic material using an electrical material? So you can use a solenoid. So for those who do not know what a solenoid is, so a solenoid basically looks like this. It's just a winding around, let's say, a tube-like thing. You can have something like this. So remember, here there's an entrance. There's a space in between. You can enter something inside here. So, and then what normally you're supposed to do is you're supposed to wind a wire around it like this. So here you can have a variable resistor to control the amount of current flowing in the circuit. So down here you can have a battery. So you can choose to have a switch here. Let us have a switch here. This is a switch. You can open or close the circuit. Now let us call this part A, this part B. So what you can do is, let's say for example you have a steel bar. Let's say for example you have a steel bar. What you can do is you need to enter your steel bar inside here, this part. So this is our steel bar, like this. So when you close this circuit, current will flow through this path, and then this steel bar, so this steel bar will get magnetized. Now how can you be able to know the north pole and the south pole from this method? For you to be able to know the north pole and south pole of this method, it will only depend on the direction of the current flowing in the circuit. So the direction of current, if it flows in this direction, then the polarity will be different than when the current flows from this direction. So we have two methods of identifying the polarity of this magnet. So one of the methods of identifying the polarity of this magnet, we have the clock rule, and two, we have the right hand grip rule. So in physics, make sure you take note of the hand that you're supposed to use. So if it's the right hand, you're supposed to use the right hand. If it's the left hand, you're supposed to use the left hand. That is very important, because if you switch the hands, then you will get a different answer. So it will be much more easier if you use the clock rule if you do not master the right hand grip rule. But if you master them both, then well and good. Now, how can we be able to know the polarity of this magnet using the clock rule? So the clock rule usually states that if one is viewing one end of a bar, let us say for example you're viewing this end of a bar, if the current flows in the clockwise direction, let me just differentiate between clockwise and anti-clockwise direction. So if this is a clock, a wall clock, we all know that the minute hand is always longer than the hour hand, and these hands usually flows in this direction, because they usually move in this direction. So if this is the minute hand, it will keep on moving in this direction. So this direction represents the clockwise direction. Let us say current, in this case current is moving in this direction and your eyes is facing this part here. So if you represent this, you'll see that this is flowing in this direction. It's flowing in this direction. So do you think that is clockwise or anti-clockwise? Now if you look keenly, you realize that it is flowing in this direction because your eyes are facing this way. So it is flowing opposite clockwise direction. So that means that this one is not in clockwise direction. But if it was to be in clockwise direction, then it means that the polarity at that part would be the south pole. The polarity of that part is the south pole. So the clock rule states that if one is viewing one end of the bar, the current flows in clockwise direction, then that end is the south pole. So if it is flowing in a clockwise direction, then that end is the south pole. And if it is in anti-clockwise, then that end is the north pole. So the best formula to use is this. You can just draw something like this. So this one represents the N, and then you can draw it like that. So the north pole is in anti-clockwise direction, and the south pole will be in clockwise direction. So this is flowing in this direction. So if it is in clockwise direction, then it is the south pole, and if it is in the anti-clockwise direction, then that is the north pole. So I think this is the best formula to use when it comes to the clock rule. You can just draw the north like this and south like this, and then the farthest end you put the pointers. So this one indicates the direction of flow of current. So if it is in the clockwise, then it is the south pole. If it is in the anti-clockwise, then that is the north pole. So that is all about the clock rule. Now let us look at the right hand grip rule. How can you be able to identify the polarity of this bar magnet using electrical method in right hand grip rule? Now something that I forgot is that, remember, whenever you are trying to magnetize a magnetic material in electrical method, you're supposed to use a direct current, not AC. Okay, so if you're trying to magnetize it, you're supposed to use a direct current. Now let us look at how you're supposed to know the polarity of this iron bar using the right hand grip rule. So you can remove this. So how can you be able to identify the polarity of this by using the right hand grip rule? So let's say for example this is the solenoid and the current is flowing in this direction like this. So what you're supposed to do is you're supposed to grip this solenoid using your right hand. So I can just draw a sketch on how you're supposed to grip. So you grip it whereby the thumb should lay like this, and then your other finger should now grab from top like this. So when you grip it like this, so what we normally say is that if a coil carrying current is grabbed in the right hand such that the finger points to the direction of current in the coil, then the thumb points to the direction of the north pole. So if you grab this solenoid like this, whereby these fingers are now pointing to the direction of flow of current. Remember, this current is flowing in this direction. It's flowing in the upper direction like this. So these fingers are pointing to the direction of flow of current like that. So it means that the thumb will point to the north pole of the induced magnet. So we remember here in the middle we have our steel bar like this. So this one will be the north pole and this one will be the south pole. So this one is the easiest method of identifying the polarity of a magnet, whereby if you grab it with your right hand, then your thumb will always point to the north pole of the magnet. And that is all about methods of magnetizing a magnet.